Owen, one of the co-founders at Fairblock, and we're going to be talking about like programmable and modular privacy using like threshold identity-based encryption and fully homomorphic encryption. To give you guys a bit of an overview about what Fairblock is, we're a modular ecosystem of privacy-enabled infrastructure and applications. So we try to be modular in the sense that we want to have users and their privacy needs met on the chain that they're wanting to use, instead of having these like fragmented L1s that each offer like an individual privacy use case. And we try to be able to support like Appchain, major L1s, rollups, and be like sort of ecosystem agnostic as we do this. We're programmable in the sense that we can use cryptography and cryptographic libraries to play around with the privacy level and conditions for having different types of encrypted transactions on chain. So you can have conditional decryption, which you can encrypt your transaction to have some certain condition be met, and once that condition is met, the transaction is decrypted and it can be executed on your own native chain that you're on. You can also do like partial encryption, where you only encrypt like certain pieces of data. So maybe you want to reveal like a limit order, you want to reveal the price but not the size. So you can play around with like the amount of data that you want to share with people. And then I guess the use case for this is eventually, if like we're all hoping that blockchain becomes sort of widely adopted, there's a bunch of regulations, regulatory talks right now, and hopefully like this allows an environment where applications can remain compliant as well as like protect users' privacy. Yeah. So like the design space for sort of the applications that can be built using us is very large. It's like a very general concept of encrypting transactions to certain conditions. But here are just like a couple of examples, like private governance, encrypted intents, randomness generation, censorship resistance, private on-chain games. These are all like very common use cases, but I'm sure there's a lot that haven't been explored yet. Here's an example of like what a potential flow might look like using our infrastructure. So in this context of like encrypted intents, where it's like limit orders and stop loss orders, a trader first submits their encrypted transaction. Here's a case of like partial encryption where the price is revealed but not the size. So people can't fully like manipulate the market to have your limit order be triggered and cause like a market impact, or manipulate it so that they can take advantage of the market impact or whatever it costs. As well as like you get to protect your trading strategy. So if you're a market maker, maybe you want to protect like the volume or the size of your orders so that people can't really like copy trade you. That sort of thing. So the flow is like pretty straightforward, and it's going to be the same for most applications building using us. So some person that's submitting this transaction encrypts it on the browser side and specifies like a condition. So they encrypt using a specific encryption key corresponding to that condition. They submit it to the native chain that they're using. It gets committed on chain, and once that condition is met, our network releases a decryption key over to the chain, and then that transaction is then decrypted and executed. Same case for auctions here. There's lately been a lot of talks about auctions. And like I think there was a paradigm paper about leaderless auctions, and sealed bid auctions are a way to ensure, I guess, like fairness in auctions, and they can prevent like censorship resistance, and it can avoid like last look MEV because intuitively the last person to make a bid has more information than the other. So if like everyone's bids are encrypted, you're sort of on like an even playing field. A few applications leveraging auctions that are being considered, like PBS, so like order flow auctions, you know, like NFT auctions, sequencer, some sort of like builder market for sequencers as well. Yeah, so the flow is exactly the same as before. Like a user encrypts their bid and submits it on chain. That bid gets committed, and then because the bid is encrypted, no one can censor you based on the bid price. So like if I'm a block proposer, I can't just like not include people's transactions who bid over me, right? So this prevents that scenario, and also like there has been work on sealed bid auctions on like Ethereum via like commit reveal schemes where people commit using some private key that they have, and then later on they reveal once the auction's over to actually like claim the winnings or whatever they got from the auction. But to avoid like attacks where I, as a person bidding, can just bid every single price and then only choose to reveal the cheapest one, they usually have some sort of like collateral posted where after the auction is over, if you reveal your bid, you get your collateral back. So our approach sort of takes away the need for this, providing better UX for people to participate in these auctions. So we have like a Cosmos L1 chain, we call it Fairblock, and it's like a key generation chain. You can think of it as like a decentralized oracle for decryption keys. So every single block, a bunch of our validators work together to, as a threshold, aggregate a decryption key that can be sent to other app chains. It can, out of the box, because it's like Cosmos Appchain, it has IBC support, so we like directly communicate via IBC to other chains, but we also have like an off-chain relayer or message passing service which can take these keys to other ecosystems like EVM-based chains. Here's a short blurb about like threshold IDE. Essentially, like there's one single global public and private key pair, and from that pair you can derive additional encryption and decryption key pairs through a particular ID. So traditionally it's like with emails, so using this one key you can encrypt to multiple emails and send it to different parties without having to regenerate keys for each person. So this solution is more like bandwidth efficient. In the context of like blockchains, out of the box our chain supports decryption based on time, so block height. And also these keys are being generated based on like price feed or oracles that we potentially will support. And in a more general fashion, applications can come to us and request a certain key whenever they need it, and a way to verify a condition, and once that condition is met, our network then releases the decryption key to them. So that's more of like a general decryption concept. It can be like ZKP, historical state on Ethereum, like that. We also have like a DKG scheme that we built in-house for like decentralized key generation. And this can be offered to like various FHE protocols, because right now FHE projects are mainly pretty centralized because it's not very efficient to run. You need like specialized hardware to run all of these run FHE programs. So there's like a QR code with some stuff that's happening. We're planning on launching public testnet right after ETH Denver. There's going to be like a Door Hacks hackathon in the works, and then more partnerships and like integrations with projects. So like we can go over a quick demo, I guess. I'm not sure how familiar you guys are with like Cosmos chains in general, but let's see. Is this easy to see? Can you guys see this?
I can't.
No.
No.
Is this better?
Okay.
Yeah,
it's
much better. Okay. So basically what I've done already is like scaffolded a Cosmos chain. So you get to see here in like the types, we use Ignite CLI to just do this really easily, but it's an auction chain with like very simple functionality. So someone can create an auction where they specify some like minimum bid starting price and some duration, so like how long the auction will last for. There's some functionality for like a person to create a bid for a particular auction, and then once the deadline has passed, the person that created the auction can then finalize it, and like all the settlement happens in this sort of transaction. So like a very basic chain with these three functionalities, but I think the point of this is just to show like how straightforward it is to integrate our module or our product into Cosmos-based chains. So yeah, we can start with the integration. All of the integration happens within like this app.go file. So we need to import like 3 modules here, or 3 different libraries, which is within the same module. So we call it the PEP module, or like the pre-execution privacy module. Essentially, using this module, it exposes messages for users to submit encrypted transactions. It has like the decryption process built on chain as well, and it has like all of the execution logic. So basically, everything on our side happens within these within this PEP module, and you only need this to integrate with other Cosmos chains. So this is just like the basic Ignite chain. So the stuff you need to modify, like basically just include this module here. We uncomment this. There's another one here. There's like some keepers that we need to have in the application. Here's the keys. So like the key store, so we need to have like some state within the module that needs to be on the application chain for our integration to work. What else do we have? So here is like the keeper function. So we have like our own keeper. Yeah, so all of this stuff is like the keeper modules that need to be implemented. So this will have all of the logic for like the encrypted transaction logic submission. And then because we are Cosmos chain, we have IBC enabled, and this is mainly for just like transferring the public key over to the integration chain so that people don't have to query our chain for this information all the time. And then here, where else? And then this is like the begin block and end block. So if you guys are familiar with Cosmos, Cosmos app chains have a special property where like block production is split into stuff that happens before regular mempool transactions, and then stuff that happens after. So because our transactions are committed in a block that's happened already, we don't want other people to have priority in the block to execute these transactions. So that's why we have like begin block logic so that these transactions are executed prior to any regular mempool transactions. And this is to prevent like actual front-running attacks. So there's just a few other lines here that need to be like uncommented. Here, then I think after this one should be ready to go. And then to import the module into the actual like Go project, we have like, you can do that here, so just uncomment this part. Yeah. So now we can just like Ignite chain build, hopefully. Oh, is it because I don't have Wi-Fi? Can I get Wi-Fi, please? Yeah. But anyway, I think I have another auction in already, probably. No, I don't think I do. Never mind, I do need Wi-Fi. Yeah, that's possible.
Bill, do you want the spot?
Yeah. I think this is a internet issue. Okay, so while this is loading, I guess we can talk about I guess we have like some tests to run through, which like takes you through the entire flow using the CLI, but we have like a front-end SDK as well. I'm not like a front-end developer, but apps can integrate this to the front end or to like a little extension to have like the encryption be done in the browser. Here it's just for the sake of presentation, like done entirely within the CLI. So there's a few scripts here. Here is like we're initiating the chain. One is for our own network fairy ring, and then one is for the auction chain that we just created. There's also like a relayer component, which is like the IBC relayer. So we're using Hermes, which is like the Rust-based IBC relayer by Informal. We also have like a fairy port, which is like a CLI tool or like client used for this off-chain messaging service for other chains. Because IBC inherently has like a few blocks delay. If you want the quickest result, it's better to use like this relayer, which essentially acts as IBC, but more like in an optimistic way, where you're just trusting this relayer to pass on the key as soon as it's available to the network. And then in this file, this is like just creating auction, submitting an encrypted bid, and then finalizing the auction. So hopefully everything works. Yeah, so here it's just creating the two chains, waiting for both of them to start running, and then also initializing like the relayer. The relayer step takes a bit of time, but I guess while this is going on, does anyone have questions about what we're doing, or whether anyone's interested in building applications using this?
Yeah. I have a question that's not directly related to what you were doing right now, but I know you mentioned earlier regarding the price feeds, right? Without utilizing this for no need for an Oracle, right? So if you were to launch, like we were talking about subnets earlier, if you were to launch a blank subnet, which is essentially a fresh blockchain, right? It needs RPCs, it needs indexers, it needs all this, it needs oracles for a lot of use cases, right? So you could say, you're saying you could essentially launch with this and have no need for a oracle if someone built the price feed using this.
I guess like if you trust the oracle on our network, you could essentially do this, but it's generally advised like you guys pick your own oracle, right? The one we have might not be reliable, or like you might want to have multiple oracles and taking an average of that, but we don't have the, I guess, like capacity on the chain to support that right now, but eventually we might build it in-house. I think it's feasible for a subnet to have a built-in oracle sort of module for them as well that they can use. Right? Okay, so here it's just testing the key share module, which is like submission of decryption keys. The auction was created already. Here's like the encrypted transaction data. So we generate a signed transaction in the browser or here locally, and we encrypt that and we submit this to the network. So you can see that after submission, like there's no bids yet because this transaction hasn't been executed yet. It's executed after the auction has finalized. So then after it's waiting for this bid to be executed, and it found the encrypted bid, which is like 1,001 tokens that we submitted for back here. So it basically took the key in, decrypted this text, and converted it into a bid message with this like bid of 1,001. And then after the auction's finalized, and we see that the settlement happens. So this was like a quick flow. Yeah.
You're talking about a network, but is that a blockchain? So does Fairblock have a blockchain that
Mhm.
actually does this? Okay, so.
Yeah, so like we have our own Cosmos L1, which handles the key stuff. It also has like CosmWasm support built in, so application developers who don't want to like bootstrap their own chain, they can come launch like their own application on our network and just use this key share module or like encryption PP module directly without the need for having to integrate this into their own chain.
Say also CosmWasm because you have your own VM and you support CosmWasm, or
Yeah, so our chain has like CosmWasm has their like WASM-D module, right? So we
Okay,
have that.
okay. Why don't you support? Why it's not EVM?
I think like
Sessions?
we are considering it. There might be like a situation where there's like both, so you can have like Polaris be like the EVM implementation on Cosmos SDK chain. Cosmos or CosmWasm just seems like more Cosmos native, which is like initially where we started, but we're definitely wanting to branch out to a lot more ecosystems. Yeah, I think that's mostly it for the demo. Does anyone have other questions they wanted to talk about?